AP Chemistry Chapter 1 video part 4. So we are going to do section 1.7, which is dimensional analysis. So many of you had a little bit of a struggle with dimensional analysis in Honors Chem, and see how you've got to get this under control. It is just unit conversion. It is not that difficult. You've got to get good at it, and you've got to be fast at it. You don't need to spend 20 minutes figuring out how to go from milliliters to liters. So dimensional analysis is using different units to calculate a quantity. A conversion factor is a fraction whose numerator and denominator are the same quantity expressed in different units. Follow the golden rule every time. So whatever unit you have in the numerator, you put it in the denominator and put the unit you either want or a unit that will get you closer to what you want in the numerator. If you have a unit you don't want in the denominator, you cancel it out by putting it in the numerator. So it's just a canceling game. That's all it is. So, number 1 says, if a woman has a mass of 115 pounds, what is her mass in grams? Use the relationship between units given on the back inside cover of the textbook, or remember the conversion factor from Honors Chemistry, 1 kilogram equals 2.2 pounds. So because this is the one that I have memorized, I'm going to use this one. However, sometimes I will use the conversion factors out of your textbook because I know a lot of times y'all pull those. Okay, so we're starting with pounds, 115 pounds. We're trying to get to grams. Okay, so I know 1 kilogram is 2.2 pounds. So I'll put my 2.2 pounds on bottom so that pounds cancel, my 1 kilogram on top. But I have to keep going because it's asked me for her mass in grams. So I use my SI prefixes chart and see that 1 kilogram is 10 to the 3 grams. My kilograms cancel. Once you get to the unit you want, that's how you know you can stop and put your equal sign. All right, so for this one, I ended up getting 52,272.72 grams, or of course if you prefer to put it in scientific notation, that would be fine. 1, 2, 3, 4. Either one works. Okay. So hopefully this is not something tricky. Now I will say in this PowerPoint there are some conversions that are going to be tricky. Probably trickier than conversions they would ask you on the AP exam. But the reason we're going to do them is I need you to get really good at them. Okay, this is just something in life you need to be good at, converting units. You do it in lots of science, lots of math classes. All right, so it says, at a particular instant in time, the Earth is judged to be this many miles from the sun. A lot of miles, 92,955,000. What is the distance in kilometers to 4 significant figures? And then it tells me 1 kilometer is 0.62137 miles. All right, so I know I'm starting with my miles. Okay, so I'll put my miles up here. So since I'm starting with miles, I want miles on bottom. So I go to the conversion factor that they so conveniently gave me in the problem. If they didn't give me a conversion factor, I'm not going to lie. I would have used, because I run cross country, that 5 kilometers is 3.1 miles personally. But this was the one your book gave you, so that's the one we'll use, which is fine. So 0.62137 miles is 1 kilometer. All right, so it asked me for distance in kilometers. So it's just a one-stepper. So I just divide. So when I divided, I got a super big number. I don't run out of room on the video. Hopefully y'all can see this. It ends in kilometers, of course, units every time. All right, but the question says, what is the distance to 4 significant figures? Okay, so this is telling me where it wants me to round. So 1 significant, 4 significant, 9 significant, 5 significant. So I need to cut off right here. So remember what I told you in the previous video. If you have to cut off places that are to the left of the decimal, you have 2 choices. You either fill them in as zeros, or you can change it to scientific notation. So for example, I could write this as my answer, and of course I'm going to change the 5 to a 6 because the 9 rounds the 6 up, and then put 1, 2, 3, 4, 5 zeros for all those extra places. So I could put this as my answer, or like I've been telling you, you can change it to scientific notation. And it would be 1, 2, 3, 4, 5, 6, 7, 8. All right, so if you look, all our answer choices are in scientific notation. So I have 1.496 times 10 to the 8 kilometers. So that would give me answer choice B. All right, so again, this is just combining dimensional analysis with significant figures. All right, so let's move on. And don't forget to be trying some of these. Okay, remember, pause the video, try it, and then compare what you get, see what you did wrong or what you did right. The average speed of a nitrogen molecule in air at 25 degrees Celsius is 515 meters per second. Convert this speed to miles per hour. And so again, it gave me the same conversion factor to get from kilometers to miles. All right, so I have a double unit here. Now, I know a lot of you like to write it just like it's typed right here, meters/seconds, and that's fine. But I need you to remember the seconds is actually in the denominator. So when you go to try to cancel it, it's going to cancel differently. So you'll see me write it like this whenever I'm converting. So that way I can physically see seconds is in the denominator. All right, so it told me how many kilometers equals 1 mile, but notice I'm starting with meters. So, and I'm trying to get to miles. So first I'm going to go from meters to kilometers. So 1 kilometer is 10 to the 3 meters. So see, I made it from meters to kilometers, but I still got to get to miles. So that's where I'll use this conversion factor. So then I can see that 1 kilometer, which I'm going to put on bottom so it will cancel, equals 0.62137 miles. So my kilometers cancel. All right, so I'm trying to get to miles per hour, so now I've gotten to miles per second. So I'm halfway there. I got the top unit, now I need to fix the bottom one. So I need to go from seconds to hours. So hopefully from Honors Chem, you remember the easiest way to do that is 1 hour is 3,600 seconds. Or you can do 1 minute is 60 seconds, 1 hour 60 minutes, but I'd rather do less conversion factors. So since seconds is in the denominator, the way I cancel is by putting it in the numerator. So 3,600 seconds equals 1 hour. So see, now seconds cancel. So that's the reason why I tell you, try not to write it like this, because then you'll visually see that seconds appears in the numerator. So a lot of you will put seconds in the denominator, try to cancel it. So just make sure you remember when it's something per something else, it's in the denominator. All right, so I just multiply across the top, divide across the bottom, and so I ended up getting for this one 1,152 miles per hour. Just like that. All right, so hopefully you're having good success with these. And y'all, it doesn't matter if you decide to change seconds to hours first or meters to miles first. It doesn't matter. The order that you multiply and divide does not make any difference. All right, so let's keep going and look at a couple more. Really, for dimensional analysis, since you've already learned this, we're just going to look at varying levels of difficulty of different types of questions. All right, and see here I just changed it to scientific notation. All right, so it says, Fabiola, who lives in Mexico City, fills her car with gas, paying 357 pesos for 40 liters. What is her fuel cost in dollars per gallon if 1 peso is $0.0759, and then it tells me 1 gallon is 3.7854 liters. Okay, and y'all, a lot of these conversion factors can be found in the back cover of your textbook, okay, or obviously online. All right, so we know she's paying pesos for liters of gas, and we're trying to figure out how many dollars per gallon. Okay, so what I would start with is how many pesos per liter. So she's spending 357 pesos per 40 liters of gas. Okay, so again, I need to change both units. It doesn't matter which one you start with. I tend to like to start with the numerator, so I'm going to do pesos first. So I can see right here that 1 peso is $0.0759. Okay, I'm going to put a dollar sign in front just because it's awkward to write dollars afterwards. All right, so pesos cancel. So see, now I have dollars per liter, but I'm trying to get to dollars per gallon. So we know that 1 gallon is almost 4 liters. Okay, so I put my liters on top so that it will cancel. than my 1 gallon on bottom. So my liters cancel, and so now you can see I have dollars per gallon. So that means I'm ready to stop and multiply and divide. So I stop, multiply, and divide, and I get $2.56 per gallon. All right, so $2.56 per gallon. And so that, of course, is E. All right, so hopefully this one wasn't too bad. Sometimes it confuses people to start with 2 numbers. So you're more than welcome to do 357 divided by 40 and then just put 1 number, pesos per liter, if you want to start with. But you can start with 2 numbers. It's okay. We're going to use both of them when we multiply across the top and divide by the bottom anyway. All right, so let's see what's next. I personally love converting, as y'all already know, so I know that y'all hate that about me, but I love converting because I think it's super logical. I like all the canceling. All right, so it says a car travels 28 miles per gallon of gasoline. What is the mileage in kilometers per liter? And then it tells me how many kilometers equals how many miles, and gallons and liters. Okay, so I'm just going to start with what I know. I know 28 miles per gallon. Okay, like I said, I like to change the numerator first. So I can see that 1 kilometer is this many miles. So I'm going to put my miles on bottom so that it will cancel. So I got to kilometers, but right now I have kilometers per gallon. I need to get to kilometers per liter. So now I need to address the denominator unit. Okay, so I can see that 1 gallon is almost 4 liters. So I put my 1 gallon on top, so it will cancel. My 3.7854 liters on bottom. So then my gallons cancel, and so you can see I have kilometers per liter, which is what the question asked me for. And so when I solved, I got about 11.9 kilometers per liter. Just like that. So all you're doing is just trying to get to the units that they ask for. Okay, because sometimes, like in gas laws problems, we might need to convert, you know, milliliters to liters if we're doing ideal gas law or something like that. So, you know, you just got to be able to convert, and it shouldn't be taking forever. Like, you got to get to where you can convert and convert in a decent amount of time. All right, so let's look at our next one. So it says, Earth's oceans contain approximately 1.36 times 10 to the 9 kilometers cubed of water. Calculate this volume in liters. So there's lots of different conversion factors you could use for this, but I go with what I make you memorize in Honors Chem. And so I told you in Honors Chem, 1 milliliter equals 1 centimeter cubed. That's the conversion factor that I expect you to know to be able to get between a distance cubed and some form of liters. So, because that's the one I have you memorize in honors, that's the way I'm going to go. Yes, are there different ways you can solve this and get the same answer? Of course, but I'm going to go with what I already have memorized, so that way I don't have to waste my time looking anything up. Okay, so I start with what I know. So I have 1.36 times 10 to the 9 kilometers cubed. So this is our first one in this video with the cubed unit. Alright, so we know that 1 kilometer is 10 to the 3 meters. But a kilometer will not cancel out a kilometer cubed. So what I have to do is cube this entire conversion factor. Okay, so by that I mean I'm cubing the units and the numbers. So when you raise an exponent to a power, you multiply them. So that's like saying 10 to the 9 on the top. And so when you plug it into the calculator, if you want to go ahead and like put what it would really be instead of putting an exponent to an exponent, you just multiply the two. All right, so see, I've made it to meters cubed, but look, I'm still trying to get to centimeters cubed. So I know that 1 centimeter is 10 to the negative 2 meters. But again, I'm trying to cancel out a meters cubed. So I need to cube this entire conversion factor. So meters cancel, so remember I told you you're just going to multiply, so this is like 10 to the negative 6. Alright, so I've made it to centimeters cubed, so now I can say, okay, great, 1 centimeter cubed equals a milliliter. Okay, so my centimeters cubed cancel, but it's asked me for liters. So my last conversion factor is 1 milliliter is 10 to the negative 3 liters. And so again, are there ways you can do this in less than 4 conversion factors? Of course. But you're not going to sit there and memorize every conversion factor in the world. So as long as you have a few base ones in your mind, sometimes it might take a little longer, but you don't have to waste time looking things up. Or if it's on the AP exam, you don't get to look things up. All right, so I just multiply across the top, divide across the bottom. And so for this one, I got 1.36 times 10 to the 21 liters. Just like that. All right, this is probably the trickiest one we've done so far. So if you pause the video and got this one right on your own, you're doing pretty awesome. The good news is on the AP exam, they're testing more of your content, and so you probably won't just have an excessively long conversion factor problem. All right, so moving on, and remember, don't forget to be trying some of these like as we go. All right, so it says a barrel of oil as measured on the oil market is equal to 1.333 U.S. barrels. A U.S. barrel is equal to 31.5 gallons. If oil is on the market at $94 per barrel, what is the price in dollars per gallon? Okay, so see, this is an example where, yes, have we ever done conversion factors with barrels of oil? No, but yes, you should be able to still do it because it gave you all the information you need. Okay, so we're starting with $94 per barrel. All right, so the first thing I need to do though is notice it's talking about this U.S. barrels. Okay, so we've got to change barrel to U.S. barrel. So I put my 1 barrel on top, my 1.333, I'm just going to call it U.S. U.S. barrel on the bottom. So now we've made it to dollars per U.S. barrel. But remember, we're trying to get to dollars per gallon. Well, it told me 1 U.S. barrel is equal to 31.5 gallons. So I can put my 1 U.S. barrel equals 31.5 gallons. So my U.S. barrel cancel, and so see now I have dollars per gallon. So I just multiply and divide. And when I do that, I got $2.24 per gallon. Just like that. See, if you know how to convert, it doesn't matter if you've ever seen these conversion factors before. You should still be able to use them. All right, so again, make sure you're trying some of these because it doesn't matter if I know how to do them. It matters if you know how to do them. That's what we're looking for, is to get you good at them. All right, so it says the surface area of Earth is 510 times 10 to the 6 kilometers squared. And 71% of this is ocean. Using the data from the sample exercise, calculate the average depth of the world's ocean in feet. Okay, so we're going to go back to where we had from our sample exercise. We're going to need this number, the 1.36 times 10 to the 9 kilometers cubed. You're going to see me use that in a minute. That's where I'm pulling it from, the sample exercise. All right, so we know the surface area of the Earth is this. Okay, so I'm going to start with that. So 510 times 10 to the 6 kilometers squared. And y'all, this was not a typo. They did just put 510 instead of 5.10 times 10 to the 8, which is fine. All right, but I just wanted you to know it's not a typo. So we have that much surface area on Earth, but only 71% is ocean. So the first thing I'm going to do is multiply it by 0.71 so I can get what the surface area of just the ocean is. All right, so once I do that, I got 3.621 times 10 to the 8 kilometers squared. Okay, so that's the surface area of just the ocean. Well, in the sample problem, they gave me the whole volume of the ocean. The whole volume of the ocean, and this is where I told you I'm going to pull that number from the sample exercise, was this right here. Okay, this is the entire volume. So if I divide that by the surface of the ocean, then I'll have the depth. And for some of you who are like, what in the world, how was I supposed to figure that out? A lot of times, y'all, it's just a game of units. It's asked me for the depth of the ocean in feet. So I know that I'm trying to get to a non-cubed or squared unit. If I have a cubed kilometers and I have a squared kilometers and I divide, I'm just going to get kilometers. And so then I can work my way to feet. All right, so kilometers squared is going to cancel. So once I divide, I get 3.76 kilometers. All right, but the problem is, of course, it wanted feet. Okay, so I know the conversion factor from Honors Chem that 1 inch equals 2.54 centimeters. So again, y'all, there's lots of different ways you can do this, but I choose to go the way the conversion factors that I have memorized. All right, so you can do it any way you want to. If you want to look up a faster conversion factor and know exactly how many kilometers are in a foot, you're more than welcome to look that up. But I just like to do stuff that I know how to do, and I don't have to spend time looking it up. So 1 kilometer, so in other words, see, I'm going to try to get to centimeters first so I can switch over to inches. So 1 kilometer is 10 to the 3 meters, so my kilometers cancel. And then I know that 1 centimeter is 10 to the negative 2 meters. So see, now I've made it to centimeters. Once I make it to centimeters, I can use this. 2.54 centimeters is 1 inch. And then once I get to inches, hopefully all of us know that 12 inches is 1 foot. So yes, did I have to use 4 conversion factors to get my answer? Yes, I did. Do you have to do it this way? No. In math, there's always more than one way to do it. I just like to do it the way that I already have memorized. So you're going to get an answer like this, but of course you're more than welcome to change it in scientific notation if you want to. So it would be 1.23 times 10 to the 1, 2, 3, 4. So either of those answers work. Okay, whenever you get a very large number, it's always best to change it to scientific notation so that way you don't have too many significant figures. All right, so let's move on. We are getting close to the end. Oh yay, a couple more. This video might be kind of long. All right, so it says, what is the mass in grams of 1 gallon of water? The density of water is 1 gram per milliliter. So y'all, that's another thing that we do in conversion sometimes in chemistry is we'll use density as a conversion factor. Okay, so we want to know the mass in grams of 1 gallon of water. So I start with my 1 gallon. Well, what am I going to do with it? Well, in some of the other ones, we use the conversion factor between gallon and liters. Okay, so if you remember, we said that, hang on, sorry, I don't have that one memorized because we don't normally use gallons in chemistry. So 1 gallon is 3.7854 liters. Okay, so that can get me to liters because if I can get to milliliters, then I can get to grams. Okay, so that's really what it is. It's like a game of you trying to figure out how to get to the answer. All right, so I can put my 1 gallon on bottom and my 3.7854 liters on top. Okay, so I made it to liters, so now I can go to milliliters. So 1 milliliter is 10 to the negative 3 liters. So liters cancel. Now I can use this, 1 gram per 1 milliliter. And see, that's how I can get to grams. So density is a good conversion factor to get between mass and volume. All right, so once I multiply and divide everything, I ended up getting about 3,785.4 grams. All right, so this one, hopefully the lack of the conversion factor in the problem wasn't a problem for you. Okay, so remember, conversion factors can be found in the back of your textbook. Because like I said, gallons is not one I personally would waste time memorizing because as you can imagine in lab, a lot of times we're not working with gallons. And here I just changed it to scientific notation. So you can have that as your answer also. All right, so y'all, we're on the last 2, so don't forget to be trying some of these on your own. So it says, composite decking is a manufactured substitute for wood compounded from post-consumer plastic and wood. It is frequently used in outdoor decks. The density of a particular composite decking is reported as 60 pounds per feet cubed. What is the density in kilograms per liter? And they gave me some conversion factors right here. All right, so let's go. So we have 60 pounds per feet cubed. Okay, and see, I see a question like this and get super excited about it personally. All right, so I told you 1 kilogram is 2.2 pounds, but you should remember that from Honors Chem. So I put my 2.2 pounds on bottom, my 1 kilogram on top. So now I have kilograms, but it's per feet cubed. I'm trying to get to liters. Okay, so I need to get from feet to liters. So again, there might be a faster way of doing it than what I'm going to do, but I'm going to use 1 milliliter equals 1 centimeter cubed. Okay, that's the way that I'm going to tackle this. All right, so I've got to get to centimeters cubed instead of feet cubed. So I know that 1 foot is 12 inches, but I also know this is cubed. So I'm going to cube this whole thing. So don't forget, you are cubing the 12. Okay, you are cubing the 12. So now I'm at inches cubed, but I'm trying to get to centimeters cubed. Well, from Honors Chem, you should know that 1 inch is 2.54 centimeters. But I'm trying to cancel out an inches cubed, so I'm going to cube this whole thing. So don't forget, you're cubing the 2.54. A lot of people for this one, if you set it up right, you have trouble getting everything in the calculator right. All right, so now I have made it to centimeters cubed. So I can use this right here. So 1 centimeter cubed equals 1 milliliter. So my centimeters cancel. So see, I've gotten to kilograms per milliliter, but I'm still trying to get to liters. So my last one is 1 milliliter is 10 to the negative 3 liters. So my milliliters cancel. Woo! So take a moment to plug all this into the calculator. Don't forget to cube the 12 and cube the 2.54. Alright, so once I did all that, I got 0.96 kilograms per liter. So then I look over here, and so obviously that's pretty much B. I just cut off 1 more decimal place. Alright, so if you got that one right, you are super awesome. Again, they probably aren't going to give you something like this on the AP exam. I just need you to be really good at converting. Okay, like when we're learning other math problems, I don't want to hear, when I say, oh, we got to convert. I want you to just be like, oh, okay, like converting. I know how to do this. It's way easier than this question right here. All right, so last one. So please try this one if you haven't been trying ones on your own yet. So it says the density of the organic compound benzene is 0.879 grams per milliliter. Calculate the mass in grams of 1 quart of benzene. And then it tells me 1 liter is 1.0567 quarts. Okay, so we have 1 quart of benzene. Okay, so obviously the first thing I'm going to do is get it away from quarts. We don't use quarts in chemistry. So let me get away from quarts and get to liters. That's something that we like to use. All right, but they gave me the density in grams per milliliter, so it would make sense for me to change to milliliters. So 1 milliliter is 10 to the negative 3 liters. So my liters cancel. I made it to milliliters. So now I can use that density as a conversion factor. It's 0.879 grams per milliliter. So my milliliters cancel. I just multiply and divide and get 831.8 grams. Just like that. All right. So the important thing about these 4 videos for Chapter 1, because most likely you're watching these because you're in my AP Chem class and I told you I'm not teaching this chapter, because you should already know it. So y'all, you should already be familiar with everything in this PowerPoint from Honors Chemistry. If you are struggling now, then it is going to be a long semester. Y'all, you have got to remember what you learned in Honors Chem. I don't have time to go back over all of it. I can't teach 2 classes in 1. All right, so if you need to rewatch the videos, you can. If you're struggling and you're stuck in this class, then you can go back to Chapter 3 lesson videos from Honors Chem, where I teach all of this much slower. All right, but good luck.